solution, the scientific method. This is how you do it.
Anyone can think like a scientist by using the scientific method.
ASI, TCI, then state your conclusion. This is the science method. Everyone can use it. ASI, TCI, then state your conclusion. You start with a problem, then end with a solution.
Sally Ride used the scientific method for experiments in space.
A for ask. Question. S for state. State your hypothesis. I for identify the variables. T for test. Test your hypothesis. C for collect. Collect your data. I for interpret. Interpret your data. S for state. State your conclusion. The scientific method. Go step by step. The scientific method. You experiment. You start with a question, try to find a solution. The scientific method. This is how you do it.
Thomas Edison used the scientific method to make important discoveries about the light bulb.
ASI, TCI, then state your conclusion. This is the science method. Everyone can use it. ASI, TCI, then state your conclusion. You start with a problem, then end with a solution.
Sir Isaac Newton used the scientific method to make discoveries about the laws of gravity.
A for ask, S for state, I for identify, T for test, C for collect, I for interpret, S for state, state your conclusion. ASI, TCI, then state your conclusion. This is the science method. Everyone can use it. ASI, TCI, then state your conclusion. You start with a problem, then end with a solution. ASI, TCI. Method.
Go step by step.
It works. The scientific method.
You experiment.
The scientific method. Go step by step.
Aha! Now you've got it.
All right, let's see.
If you like this video.
So, over here on the left-hand side of the screen, it says, if you could do any science experiment, what would it be? And I'm looking and I don't see any responses except for Haley. She said the egg drop. That would be a good one. Come on, give me some more ideas. Let's go, guys. If you could do any science experiment, ooh, make gas. Ooh, we can do that this year. Ooh, can a potato charge a phone? All right, Hershey Kisses toothpaste. Exploding volcano. That volcano keeps popping up. Let's see. Ooh, elephant toothpaste. Yes, yes. Somebody in my homeroom said that earlier. Let's see, what else? Oh, make kittens stay forever a kitten. I don't know that I'm quite skilled scientist enough for that one. All right, stopping COVID. All right. Let's see. Any other ideas? Oobleck. Ooh, I like Oobleck. That's cool. Corn dog, Monster Energy. Ooh, Coca-Cola and Mentos. Slime. Pig dragon fire. I don't know what that is. Ooh, make something explode. Ooh, make a can crush with hot and cold water. Ooh. That's interesting. I'm going to have to look into that one. Make a can crush with hot and cold water. That actually could be something we can do in this unit coming right up. All right. 10 more seconds. 10. Mixing stuff. We'll definitely do that this year. 5 more seconds. Shake sides up and open them. Do stuff. All right, we're definitely going to do stuff this year. All right, time's up. Thank you so much for your responses and your engagement in our lesson. So, that being said, I'm glad someone said one of the things that I had in mind Someone in my homeroom said it earlier. Some people have been talking about it in the Flipgrid for the assignment today. But that brings me to my next slide. And we, your teachers, need your help. So I saw the Coca-Cola and Mentos challenge. The enhancement teachers have challenged all the grade levels to see who can get the most students registered for their enhancement Google Classroom. So right now, after I'm done telling you about this, I need you to go to your Google Classroom and add all 5 classes. Now listen, if 5th grade has the highest percentage, then your awesome teachers are going to allow the enhancement teachers to drop Mentos in Diet Coke and point it at them. So it is in your hands and your classmates' hands as to whether or not you get to see your teachers splattered with Diet Coke tomorrow afternoon at 1:15. So tune in tomorrow at Science to find out if we're going to take some Diet Coke to the face. But before that happens, we need you to help us out. And we need for you to add these classes to your Google Classroom. So, first, you're going to open your Google Classroom app. Second, you're going to click that little arrow in the top right-hand corner and click Join Class. And when Join Class comes up, you are going to enter these 5 class codes. Can they copy and paste from the chat? No? Bummer. So my suggestion would be to get a piece of paper and write these down real quick and then go do it. Or you can do them one at a time. That's completely up to you. But I do not see all 5th graders in the science lesson today. So it is going to be really important for you guys to take note of any of your friends who are not here and make sure that they sign up for the Google Classroom.
Ms. Hernandez, we actually can copy and paste from the chat.
Oh, really?
Yes, I've done it before.
Well, cool. I'm gonna put these codes in the chat, and if you can copy and paste, then that'll be fantastic. If not, you're just gonna have to.
I already did the classes.
Okay, everybody hasn't, so let's let everybody have an opportunity to do that. Thank you so much for being proactive and making sure yours is done. That is incredible. I really appreciate that. That tells me that you've been using your agenda.
Maeve, yes ma'am, you have a question or something that's going to benefit the whole group?
Okay, I'm pretty sure if you go to the enhancement playlist, it will say that something Google Class, and then you can just click Join Classroom. You don't have to enter the code, I'm pretty sure, because I just did that.
Maeve, incredible. So you can also go to Echo in the enhancement playlist and just click. Just do that, guys. And while you're doing that, listen to the super cool song.
Everybody go up. Nothing can stop me. I'm all the way up. All the way up.
Alrighty. There are 5 codes. There's 5.
It doesn't work. It says for me that I'm still in Miss Anderson's class.
You should be able to add more than one classroom to your Google Classroom. So
Yep, join class.
either click the link or see if you can click the add button up in the top.
The add button is actually at the bottom for iPads.
Oh, cool. Thank you for that. And you are correct. I remember I did that with Bash. Perfecto. Thank you so much. Nelly, you are on it. I love it.
When I did it, it only popped up music.
All right, so then you need to enter in another code. You have 5 different codes that you have. All right, so that being said, we are going to continue. All right, so your assignment for Wednesday was talking about theory versus hypothesis. So, one brave lady or gentleman, please unmute yourself and tell me, what is a hypothesis?
It is a theory that needs to be tested.
It is a theory that needs to be tested. Okay, so who are
That hasn't already been tested.
okay, so it's a theory that hasn't already been tested. All right, mute yourself. Somebody else add to that.
Hypothesis is a educated guess.
Okay, it's an educated guess. All right, perfect. Elliot?
A hypothesis is a guess with a little bit of stuff you know, and then a little bit of stuff like that you might think will happen. And it's like something that can be changed.
Okay,
Something.
so it can be changed based upon what you find in your experiment. Very good. All right, next up is, what is a theory? What is a theory? If you have not answered, I only want to hear from people that I have not heard from yet. Unmute yourself and tell me, what is a theory?
A theory is backed up with a lot of.
Okay, I'm sorry, Cullen, you were speaking and someone else unmuted. I would love for you to repeat yourself. No? Okay,
If the other person wants to talk, they can talk.
all right. I see Jamari's hand.
A theory is something that that you said that you tested it and I forgot what I was gonna say.
Okay, very good. A theory has been tested. That's a good point. Ocean, thank you for raising your hand.
A theory is like, it's almost like a hypothesis, but it's been tested for a long time. And it's just been tested a lot in the past.
Okay. And Maeve. And I have one more question. So for those of you who are ready to respond, if you want to keep your hand up, I can call on you in just a moment. Maeve, go ahead. What is a theory in your opinion?
I feel like a theory, as someone already said, I forgot, I'm sorry. I feel like a theory is a lot like a hypothesis, but it's like, I feel like it's like what you think the outcome of the hypothesis would be.
Okay. So maybe what you think the outcome of the hypothesis would be. All right. So my next question is, how is a theory and a hypothesis different? All right. Braxton, how is a theory and a hypothesis different?
A theory and a hypothesis are different because a hypothesis is just a guess at what would happen, and a theory is something that has been tested already, and hypothesis has not been tested yet.
Okay. Colin, I see your hand raised. Would you like to tell me how they're different?
They're different because of what. Never mind.
Okay. Lauren, how are they different?
A theory and a hypothesis are different because a theory is has been researched and is like true, and a hypothesis is just a guess.
Okay. So a hypothesis is just a guess. A theory's been researched a little bit more. Excellent. What about you, Naha?
A hypothesis is like it's only been like tested like once and it can still be wrong, but a theory is it it's tested multiple times.
Okay, so a theory's been tested multiple times. All right, I like that you added that there. And Kaylee, do you have anything else that you can add to the discussion?
A hypothesis is just a guess on why something happens the way it does, and a theory is something that has been tested multiple times by multiple different people, and they have all gotten the same answer.
All right, excellent. So sometimes a hypothesis may be just a guess based on some evidence or observations that one person has. And a theory could be the compilation of multiple people's research and experiments and guesses. So in a nice handy dandy chart, if I were to compare these two, hypothesis and theory, a hypothesis is a proposed explanation for a natural phenomenon. This happens because of that. But a theory goes a little bit further, and it actually explains that phenomenon and maybe even why it happens. Your hypothesis is what you predict or you guess before an experiment has ever happened. So it's not scientifically tested or proven. However, the theory has been tested and proven, and many of you said that it's been tested multiple times. It's got lots of evidence to support it. And then a hypothesis is based on a smaller scale, and your theory, kind of like Kaylee was saying, is based on a wide range of data. You've got lots of data to support whatever the theory is. So excellent job, guys. I will be providing feedback on those responses this evening. So please make sure you guys are checking your activity stream and Echo to see what feedback I'll leave for you. So today, before you guys are released to go to your Flipgrid, we're going to kind of go through a practice experiment together. This experiment is going to be talking about the effects of fertilizer on the growth of orchids. And an orchid is a kind of flower. So this says that you want to determine the effect of a certain fertilizer on the growth of orchards grown in a greenhouse. Materials that are available to you include a greenhouse, 100 orchid plants, water, fertilizer, and soil. You want to know if the orchids will grow best with a weak concentration of fertilizer, a medium concentration of fertilizer, or a high concentration of fertilizer. How will you design an experiment to test different concentrations of this fertilizer? First of all, I've got two words underlined here in this bottom paragraph. Someone who I haven't heard from today, tell me why I might have those words underlined.
Because they're very important.
Okay, they could be very important. Excellent. Do you need to know what a concentration in fertilizer is in order to be able to do this experiment effectively? Yeah, I see some heads nodding. Yes, we definitely do. Why else might these words be underlined?
Because there might be words that we need to know.
Okay, yes, they might be words that we need to know. And as fifth graders, we might not know those words right off the top of our heads. So you always need to try to find the meaning of terms that you don't know before you try to answer the question. And the question here is, how will you design an experiment to test different concentrations of this fertilizer? If we don't know what a concentration or a fertilizer is, we can't answer this question. So I'm just going to go ahead, to save us time, I'm going to tell you what these two things mean. So a concentration is how much of the substance is in a solution. So, and make sure you're muted while I'm talking.
Ms. Hernandez, you're muted.
Okay. So Kool-Aid with a very high concentration of Kool-Aid in it is going to be like really powerful. However, watery Kool-Aid has a lower concentration. It has a weak concentration. There's not enough Kool-Aid in it. And then fertilizer is something that people put on plants to help them grow. So fertilizer helps plants grow, and a concentration tells us how much of a substance is in a solution. So know that we want to design an experiment to test different levels of fertilizer, something that helps plants grow. How might we, or what might our hypothesis be? If we're putting different amounts of fertilizer on plants to see how it affects their growth, what might our hypothesis be?
How big it grows?
Okay. Yeah, but we've got to use something about the fertilizer in there too. We've got to use all the parts. So something about how it grows. Can somebody else add to that idea?
The hypothesis could be how much fertilizer will it take to make the plant grow?
Okay, so you gave me a question. So let's see if we can make that as a statement. Because remember, a hypothesis is a guess. So blank will happen if we do this. Elliot, go ahead. Nope. All right, so I'm going to go ahead and give you this one, but I'm going to look for your responses in the future. Whoa, sorry. So a hypothesis for this might be that plants will grow more with I know that fertilizer helps plants to grow. So maybe I would say that the plants would grow bigger if they have a higher concentration of fertilizer. Or maybe you might think the plants would grow better if they have a medium concentration of fertilizer. Or you might say plants would grow best if you leave them alone and don't give them fertilizer at all. Or maybe plants would grow best if you give them a weak amount of fertilizer or a small amount. So those would be examples of a hypothesis for this experiment. If plants receive a weak concentration or a medium, since that's right in the middle, that might be a good one. If plants receive a medium concentration of fertilizer, they will grow best. So that's what we're going to go with for this one. So how are we going to set this experiment up? First of all, we have 100 orchid plants. And remember that when we do an experiment, we have to have one group that is untouched, right? One control group, that's the group that is not touched. And then you have your experimental groups. Those are the groups that you're applying changes to. You're applying the different variable to. So we have one group that's not touched, the control, so they receive no fertilizer. One group that receives a low amount or a weak concentration of fertilizer, one group that receives a medium amount, and then one group that receives a high amount. So if we need 4 different groups, how might we set up this experiment of 100 orchid plants? All right, Samira, I see your hand raised. Thank you. You may unmute yourself.
I want to set it up as 4 plants near the sunshine and then have fertilizer. And putting the fertilizer in each one except for one and see how will it do.
Okay, so I just said I needed to split up 100 plants into 4 groups. How many plants are going to be in each group?
1.
Okay, I want to give everybody a chance to think, okay? So let's make sure we're muted. And if you want to share something, make sure you raise your hand. If we have 100 plants and we are splitting them equally into 4 groups, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. How many plants are going to be in each group if I split the 100 into 4 equal groups? Kaylee, I see your hand raised. You may answer.
There will be 25 orchid plants in each group.
Excellent. So if we divide our 100 plants into 4 equal groups, so we have 1 control, they're just going to receive plain water, and then 3 different groups that receive 3 different levels of fertilizer, we're going to have 4 groups of 25. So 4 are going to receive just water. 25 is going to receive water. 25 will receive a weak concentration. 25 will receive a medium concentration, and 25 will receive a high concentration of fertilizer. They're going to be watered daily using that concentration of fertilizer. And over the period of a month, they're going to be measured to see which one grows the tallest. So in this experiment, I've already said it, so this should be an easy one for you guys. Raise your hand if you can tell me what is the control group in this experiment. What is the group that is not being changed? Someone I have not heard from yet. What is the control? What is the group that is not going to be changed today? Jamari, you may answer.
I think it's the
What is the group that's not going to change? There's not going to be any changes to it.
the control group. The control group.
But what is the control group? What type of plants are they going to be? What kind of water are they going to receive? If we don't want any changes to happen to the control group, what type of water will they receive?
None.
Well, they got to receive water because we have to keep the treatment.
Why I sign up for some?
Hold on, they're going to receive no what? No water or no fertilizer?
No fertilizer.
Exactly. The control group is just going to receive plain water. They're not going to receive any fertilizer. Now, what are our experimental groups? What are the experimental groups? If the control groups are the groups that are just getting plain water, what is the experimental group?
The ones that are getting the fertilizer?
Yes, definitely. The ones that are getting the different levels of fertilizer. So 75 plants are going to get different levels of fertilizer. So the control group is really important because if you don't have a control, and this is going to be on your flip grid, if you do not have a control, you have nothing to compare your experiment to. If we experimented with all of them, we gave all the plants fertilizer, then we wouldn't know if they didn't receive fertilizer, if they would grow just as tall. So you have to have something to compare it to. And then the experimental group, of course, that is important because we've got to have something to test the changes that are proposed. So in a controlled experiment, all the variables must be kept constant except the variable that is being changed. So if we're talking about growing plants, what would you guys assume would stay the same for all the plants? If we want them all to remain healthy, if you want to grow a healthy plant, what are some things that you know plants need?
Soil and plant food.
Yes, but next time raise your
Also water.
hand. Raise your hand before you speak. That way I can make sure we don't talk over one another. I know usually I tell you guys just to unmute yourself. But make sure you just raise your hand from now on so that we don't talk over one another. So yes, Nellie, go ahead.
The plants, since I had a garden, they need lots of water, good soil, and plant food.
Okay, so they
And
need
sunshine.
Okay, all right, and I'm seeing in the chat as well that we need some sun, we need water, we need soil. All right, Naha, is there anything that hasn't been mentioned?
Well, I was just gonna say not the water from your sink because that can kill the plants because it has like salt and chlorine in it. So
Alright.
use rainwater.
Okay, yep, some tap water does have chemicals in it, which could be harmful to plants. And Samira, is there anything that we have not mentioned yet? Okay. So, yes, they must all receive the same amount of water each day. And they all have to be grown in pots the same size with the same soil. Okay? So you guys said soil. And one of the things that hasn't been mentioned is that they all have to be kept at the same temperature, because we know that sometimes cold temperatures can be detrimental to the health of a plant. And then, of course, the same amount of sunlight. We have to keep those things the same. Now, what is being changed in this experiment? What is the variable that we're adding, that we're testing? Cammie, can you tell me what we're adding that's being tested? Because this is the variable in the experiment.
Actually, I just wanted to add on, I think Naha said it. She was talking about how the water has chemicals in it or something.
Mm-hmm.
It also has like lead in it, and sometimes the water doesn't get filtered right, and it can still have parts of like when people go to the restroom.
Okay, thank you. Thank you. Yes, sometimes the tap water can be contaminated, but sometimes we've got to use what we got. So thank you for adding that in there. But for the sake of time, we've got to answer this question here. What variable is being changed in this experiment? What are we testing? What is being tested here? I'm looking for someone who has not answered yet. What are we changing in the 4 different groups? What's being changed? Ansley, can you tell me what is being changed in this experiment? What is the one thing that's being given differently to each group of plants? Okay, and remember, we want to know if the orchids will grow best with a weak concentration of fertilizer, a medium concentration of fertilizer, or a high concentration of fertilizer. So what are we changing in this experiment for each group? Yes, thank you, Alicia and Joshua. We are changing the amount of fertilizer. Excellent job. That is the variable that is being changed. All right. So after a month, and I'm just going to go through this really quickly because you guys need to have time to do your flip grid. Over a month, group 1 with just water grew an average height of 15 centimeters. The weak concentration group grew an average height of 35 centimeters. The medium concentration grew an average height of 28 centimeters, and the high concentration grew an average height of 10 centimeters. So my hypothesis was I was going to keep it safe and in the middle, and I was going to say the medium concentration group would grow the best. Was my hypothesis supported or not supported by these results? It was not supported. Thank you for commenting in the chat. Very good. It was not supported because obviously the medium group was not the one that grew the highest. So our results do not support our hypothesis. So based on these results, what would our conclusion be? Which concentration is most effective for growing plants? Is it the control group? No, just water. A weak concentration, medium, or high concentration? Which of these is most effective? All right, Samira, I see your hand raised.
The weak concentration.
That's right. The weak concentration is the most effective because those plants grew an average height of 35 centimeters. Okay. So, but that being said, it is extremely important that maybe we at least conduct this experiment at least one more time to make sure there wasn't any errors, or maybe it was just like a coincidence that it happened that way. We kind of want to receive the same results, maybe, I don't know, at least 2 or 3 times before we can confirm a hypothesis. So that would be a good example for the why is it important to repeat the experiment many times. All right, just so we've got some good evidence to be able to prove or disprove our hypothesis. Because we always have to leave room for some human error in there. All right, guys, so our time together is up. It is time for you to complete your Flipgrid discussion. If you all have any questions, hang out, and if not, you are free to go. I love you lots. Thanks for using your science brain today.